Hi everyone, my name is Julien and I'm a tech evangelist with AWS, focusing on AI and machine learning. In this session, we're going to dive deep on a capability of SageMaker called Amazon SageMaker Autopilot. And as you probably know, Autopilot was launched at reInvent in last December, and it adds AutoML capabilities to SageMaker. So in this session, I will go through a Jupyter notebook that shows you how to configure and launch an autopilot job. And then at the end, I'll show you how to do the same thing using only the SageMaker Studio graphical interface without writing a line of code. Okay, so let's get started. So we're starting from SageMaker Studio, and this notebook is available on GitLab, as you can see here. And if you want much more content, you can find me on Twitter and YouTube as well for more videos and demos. Okay, so in this notebook, we're going to use a data set called the direct marketing data set. And the first step, obviously, will be to import the Sagemaker SDK and then download this data set. Okay, so we just download it from the internet, extract it, and it's a CSV data set. So we can easily use pandas, which is really the Swiss Army knife of data science, to visualize it. Okay, so this is what the data set looks like. Here are the first 10 lines. We see, I think, 20 features describing customers, age, marital status, education, etc., etc. We have some additional columns here. And at the very end, we have this column called Y. And Y is the label. Y tells us if yes or no this customer accepted the marketing offer. Okay, so we see a whole bunch of no's because most people will say no to a marketing offer, but trust me, there are some yeses as well. Okay, so this is really the raw data set. It has a little more than 41,000 lines, as you can see, and so 20 features and one label. So if we were using traditional machine learning, we would then move on to feature engineering and cleaning up the data set and doing all kinds of tricks on that data to make it easier for the algorithm to learn. But here we're not going to do any of this. We're going to start from this data set and just process it just like that. The only thing I'm going to do is I'm going to split it. I'm going to keep 5% for me on the side, right? So 95% goes to SageMaker Autopilot, and I'm going to keep 5% on the side for testing at the end. So don't keep too much for yourself, because the chunk that you give to SageMaker Autopilot will be further split for training and validation. So you want to give Autopilot as much data as possible. Okay. So again, this split is just my decision here to keep some data on the side. Okay, so I can see my two CSV files, right? And well, I'm just uploading the training chunk, okay, to S3. And here we're using the default S3 bucket that SageMaker creates for us, so we don't need to create one, right? If you want to use your own, that's perfectly okay, right? Then just to make sure the data is in the right place. And I'm just adding a prefix to keep things nice and tidy here. Okay, so this is the location of the training set in S3. Okay, and this is as much data wrangling that you have to do with Autopilot. Okay, just put it in S3. Simple enough. Okay, now we can move on to setting up our job. And well, we're going to use this AutoML object from the SageMaker SDK, and it's really one line of code. Okay, so let's take a look. The first parameter is the role, okay, which we get from SageMaker Studio here. You would get it from a notebook instance if you were running there, or you could use any IAM role if you were running locally, maybe. So just pass a role that allows Autopilot to access S3 and do all kinds of other things. The session is just a technical object. We don't need to worry about this. The target attribute is really, really important. So it's the name of the column that you want to predict. Okay, so as we just saw in that data set, that label column is called Y. Okay, so this really needs to be the exact name. Then we pass the output path. So where do we want to store all the training artifacts? And we'll see there are quite a few pre-processed data sets and models, etc. And you could stop there. Okay, so just for the sake of completeness, here are a couple more parameters that we can pass. So this first parameter actually caps the maximum runtime for an individual training job. So here I'm saying, hey, no training job should last for more than 10 minutes. And as you will see later on, these jobs are really, really short. Most of them are just under a minute because it is a really small data set. So I guess that's just a way to protect myself against some kind of outlier training job that would fire up and with a weird combination of hyperparameters, and that would last much longer than expected. Okay, and I can also cap the maximum runtime of the AutoML job. So this one is good for dev and test. I don't actually recommend that you set this in production because it's going to limit the number of options that Autopilot has to tune your models. So by default, I would not use this. Just let it run for as long as it wants to, and which is going to be hours and hours depending on the data set. And this is how you will get the best accuracy. But here, for demo purposes and quick testing, it's fine, right? Okay, so now the AutoML job is configured, and I can just launch it by calling the fit API and passing the location of data, right? This is the S3 path that we saw here, okay? So where's the data? I'm turning logs off because I don't want to read the hundreds of logs, and I'm asking that API to be non-blocking because I want to check the status of the job. If you want to block until completion of the job, then you would just say wait equal true, which I believe is the default setting anyway. Okay, so now the job fires up, okay, and I can use the describe API to check its status. So it does return quite a lot of stuff. We can see the location of data, but the things I'm most interested in right now are these. Okay, so the status of the job, which could be in progress, stopped, or completed, and the secondary status, which tells me in which at which step the AutoML job is. So of course initially it is starting, and pretty quickly it's going to start going through 3 steps. Okay, so the first step is called analyzing data, and this is where Autopilot inspects the data set, figures out what type of problem we're trying to solve. Okay, because hey, if we go back here, we never said we wanted to build a binary classification model, right? So we could. There's actually a parameter to say, well, this is the type of problem I'm trying to solve. So it's either binary classification, multi-class classification, or regression, or you can just let Autopilot figure it out, which is what I've done here, right? Maybe you caught that. So it's going to figure out what type of problem I'm trying to solve, and it's going to build 10 candidate pipelines that will be used to train models. So a pipeline is a combination of a pre-processing step and a training step. Okay, so very similar to what you would do yourself, pre-processing data, feature engineering, etc., and then training an algorithm on that processed data set. So that's what the data the analyzing data or data analysis step does, and we can wait for it to complete with this simple loop, right? Checking job status every 30 seconds, and then basically exiting the loop once analyzing data is complete. Okay, so once this step is complete, and here on this data set, it's pretty short. It probably lasts for about 5 to 7 minutes, something like that, very short. Once it's over, we can actually start looking at a couple of generated notebooks. Okay, so you can find the path to those notebooks in the describe AutoML job response, and as you would expect, they are stored in S3. And of course, we can copy them locally, right, to whatever instance or machine we're using for this notebook. Okay, So let's take a look, because those are really important, right? And we can go back to the AutoML job after that. So the first notebook that's generated is called the Data Exploration Notebook. And well, that's a pretty self-explanatory name. It's going to tell us about the data set. So it's going to basically show us a sample of the data set, which is always useful, I suppose. It's going to tell us about missing values in the data set. It's going to give us some statistics on the columns, right, etc., etc., descriptive stats. Okay, so this is really stuff that you would do. You would do yourself, right? I mean, this is probably the first thing you would do when working with a new data set. So nothing very fancy, but the fact that it's automated just makes it simpler. And imagine working with 10 or 100 different data sets in parallel, trying to figure out which one is actually the most interesting one. Well, of course, you don't want to compute stats on 100 data sets yourself, so you can just let Autopilot do that. Okay, and so we see median values and min max, etc., etc. Okay, so pretty cool stuff. And more interesting is the candidate definition notebook. So the candidate definition notebook actually shows us what the pipelines are. Okay, and the really cool thing is this is a runnable notebook. So it's not just documentation, it is actually code you can run. Okay, so let's take a quick look at the at one of the pipelines. Okay, and then we'll go back to the AutoML process. So the first few cells are just about setup and copying config files so that you can run that stuff locally. Okay, so nothing really super important here. And then we create a runner object. So that's an object that will let us run those pipelines. And then we see the 10 candidates. Okay, and they have this naming convention, DPP, which probably stands for Data Processing Pipeline, something like that. And so we go from DPP 0 to DPP 9. Okay, and we can read about this first pipeline. So this first pipeline transforms numerical features using an object called robust imputer, which will fill in missing values. And it's going to encode categorical features with an object called threshold one-hot encoder. And then it scales everything with a third object called robust standard scaler. And then the transform data is used to train and tune an XGBoost model. Okay, and we can see infrastructure training requirements here. Okay. So you might wonder, okay, yeah, that's all right, but what are those objects? So if you're curious about robust imputer, well, you just click on this, and this takes you to the appropriate file in a GitHub repo where you can actually see the code for that object. Okay, and we learned that it is based on sklearn impute simple imputer with edit functionality, and you can keep reading, and of course, the code is there for you to read and understand. So this is again one of the key features in Autopilot, in the sense that you can exactly see how data is going to be processed. Okay, and you can look at all those other objects as well. So you can see exactly what's going on, and you get full transparency over data preprocessing. So you can understand how it goes, you can explain it to your stakeholders, you can compare it to the way you've been doing things manually, maybe, right? See, hey, this is pretty much what we were doing ourselves, so okay, fine, this is reasonable. Or maybe it's adding an extra step, and okay, we never tried this before. So I think this is pretty interesting. If we look at another one, maybe just quickly, okay, we can see this one pretty much uses the same objects, and it's adding a PCA step for dimensionality reduction. So why not try that? Okay, I think it's one of the reasonable things to try. And then again, it's training with the XGBoost, etc., etc. So you can go and see all those 10 pipelines. You can see this one is actually not using XGBoost. It's using the linear learner algo, which is another one of the built-in algos in SageMaker, etc., etc. Right? So you can select the pipelines that you want to run, and then you can see, okay, you can double check which one you actually selected, And if you want to see the exact code that's used to run the pipeline, you can see it as well. Okay, so this is based on a scikit-learn pipeline. And we can see this code building a pipeline for the numerical fields and numerical features and the categorical features, putting everything together, etc., etc. Okay, so again, full transparency on how this stuff works. And finally, you can run it, right? So I run it already, and we can see we're firing up a first job that's going to train the transformers on the input data set, and then it fires up a second batch transform job to process the input data set with the transformer model. Okay, and so at the end of this step, what you have in S3 is a processed version of the data set. Okay, so if you do this for the 10 pipelines, then you end up having 10 different pipelines, pipeline processed data sets. Okay, and then it goes on to hyperparameter tuning, etc., etc. So I'll go back to the AutoML job for now, but this is just a quick run through this candidate notebook, and I think this is again one of the highlights of Autopilot, because you can understand how the model is built, and if you want to keep tweaking, if you want to keep refining the training job, then you can absolutely do that, right, using domain knowledge and your own black magic data science tricks, right? Okay, so let's go back to the notebook. So after the data analysis step, we move on to feature engineering, which is pretty much exactly what we saw in the notebook. Okay, so we use the pipeline definition to process the input data set and store a processed copy in S3. Okay, and again, we do this for each pipeline. Okay, so we keep looping until that feature engineering step is running, and then at some point it completes. And then the job moves on to the final step, which is model tuning. Okay, so now for each pipeline, using the algo that was defined for that pipeline, so XJBoost or linear learner, etc., Autopilot will launch an automatic model tuning job using the algo and the processed data set for that pipeline. Okay, so that's going to happen 10 times because we have 10 pipelines. And for each of those pipelines, we're going to fire up by default 50 tuning jobs. Okay, so eventually we're going to get to 500 models. Okay, and this is why this thing runs for a few hours if you don't cap it. Okay, but this is how you get high quality results as well. So as soon as model tuning starts, you can actually use another SageMaker capability called SageMaker Experiments that lets you visualize the ongoing jobs. Okay, so as soon as model tuning starts, you can do that. You don't have to wait for the job to complete to see this. Okay, you would also see it in SageMaker Studio. So here my job is complete, so there are no blinking lights. But if you describe your AutoML job, which you would see here in the experiments category, you would see the jobs in progress and the jobs completing and their metrics showing up, etc. So it would definitely blink here. Okay, but we're using APIs for now. So all it takes to visualize the jobs is to create an experiment analytics object, passing the name of the experiment. So in this case, it's going to be the AutoML job with an extra string at the end. Okay, and you can convert this to a pandas data frame, right? And then I would say it's business as usual because it's just vanilla pandas. So for example, I can print out the number of jobs that I've already run, and I can use pandas in many different ways to visualize this. So here I'm just moving the objective metric column to the front, right, to make it easier to read because it's buried somewhere in that data frame. And then I'm just showing the top 5 jobs by descending metric, as we can see here. Okay, And I can see the top one at this point was 91.85%. Okay, this metric by default is going to be accuracy, validation accuracy, because we just set everything, to default. We can actually, for classification jobs, we can actually select the F1 score as well if you want. And for other types of jobs, you get other metrics. But here it's validation accuracy. And of course, we can see all the information, and we can see the hyperparameters that were tried out for that job, etc., etc. Okay, so there's a lot of metadata here for you to look at and analyze, right? Okay, so at some point, model tuning completes. So we've run all those jobs, and now we're done with the AutoML job, right? And so you would get to that point where you see all the jobs that I've completed. So here's my best job again. Of course, we can sort them using all the column headers here, and the top job has this star. So I could open this specific tuning job, and I can see the associated jobs, right? So I can see, the information on the processing, on the data processing job that's associated to this tuning job, etc. So you can, again, you have a lot of traceability information to see, okay, what is this job? What are the metrics? What are the parameters? What data was it trained on? Where's the saved model? And of course, the input artifact here, that data set, you can see it comes from the DPP4 pipeline, would come from those previous jobs that have been run during the pre-processing step, right? So you can exactly trace how you went from the input data all the way to the model, okay? So lots of information here. Now we could also build plots, but in the interest of time, I'm not going to do this, but you can actually select those jobs, and you can add charts and build pretty cool plots showing you, comparing those jobs and helping you figure out which one you want to actually deploy. Maybe it's the top one, maybe it's one of the top ones, maybe that's better qualities. Okay, and how would you deploy it? Well, it's very simple. You would just create an endpoint name and call the deploy API on the AutoML object, passing your infrastructure requirements for the endpoint. And after a few minutes, the endpoint is up, and you can use it and predict, right? With just like any other SageMaker model. Okay, and of course, then you would delete the endpoint, and you might want to clean up all that stuff in S3, all the artifacts and all the trained models, etc., etc. This is how you do it, and you can see these steps in detail in the notebook. Okay, but again, once the model is deployed, then it's SageMaker again, business as usual. Just predict with it, and this is no different from a single model that you would have trained yourself. Okay. All right, so this is really it when it comes to autopilot with the SDK. So summing things up, upload your data to S3, and then configure that AutoML object here. Okay, and remember, you can the really important one is, of course, the target attribute, and then you can pass you can let autopilot figure out which problem you want to solve. Okay, or you could specifically pass a parameter saying, hey, this is binary classification, and then please use F1. Okay, and then from then on, it just runs, and you get a model that you deploy. Okay, so now let me show you how we would do this without writing any code. Okay, so we just need to know one thing. We just need to know where the data lives. So let me copy this, and then I would go to the experiment tab, right? And I would click on create experiment. Okay, so let's give it a name. So let's call this Summit AutoML job. Okay, then I would pass the location of my data, right? exactly what we used for the API. Then I would pass the name of the target attribute. Okay. Then I would pass the output location. So let's maybe store everything in here, right? And then I would select the machine learning problem I'm trying to solve. Okay, so either just leave auto by default, or I could say, hey, binary classification, and I want to use F1. Okay, well, let's do this for a change. Okay, and if we select other types of jobs, we see other metrics, of course. Okay, so let's use F1. And then I would finally select whether I want to run a full experiment. Okay, so going through the full process, just like I showed you in the previous notebook. Or I could just say, no, I just want you to run data analysis and generate notebooks. So why would you do that? Well, I think you would do that if you wanted to, if you wanted to run those pipelines yourself. So you want Autopilot to do the analysis job and build the pipelines, and then you would want to read those pipelines, run them yourselves, keep tweaking them, etc., etc. Because you have domain knowledge and you want to have control over that part of the machine learning process. So you could absolutely do that, and then the job would stop once the notebooks have been generated. So let's run the full experiment. Okay, and that's it. We just click on create, and off it goes, right? So now we should see some blinking lights. So we see those 3 steps, right? Analyzing data, feature engineering, model tuning, and these obviously match what I presented in the previous notebook. Okay, so I'll just pause the video for a minute or two, and I'll be back once we see jobs running. So after a few minutes, the analyzing data step is complete, as you can see here. So what we've done here is basically generate the pipelines, and we can see that in the top right corner here, we can see links to the 2 notebooks that we took a look at. Okay, so then the job moves on to feature engineering. So it's going to transform the data set using the pre-processing pipelines, and that's going to take a few more minutes. So again, I'll pause the video and I'll be back when this is complete. Now the feature engineering step is complete, and we've moved on to model tuning. Okay, so this is where we use the processed versions of the dataset and the algos that are defined in the pipelines to launch hyperparameter tuning jobs. Okay, and so we see initially here we see those 10 jobs starting because we have 10 pipelines. Okay, and these jobs will complete, and hyperparameter optimization will apply, and new jobs will be launched with optimized hyperparameters. And gradually, over time, we're converging to high accuracy models. Okay, so this is going to run for a while, and we've seen the rest of the process. So I think that concludes this presentation. Thank you very much for attending. I hope you learned a few things. Once again, you can find the notebook code on GitLab, right? And if you like to keep in touch with machine learning and Sagemaker at AWS, you can follow me on Twitter and on YouTube for more content. Thank you very much, and enjoy the rest of your day.